Okay, let's pick up where we left off with O3, but now we're going to talk about formal charge. Now, it's only, if I were to do the formal charge of the other resonance structure, it would look identical to this, just flipped with the 2 oxygens, so I'm not going to bother doing that. And maybe I should have kept the structure where we started to draw the Lewis structure. I'll just do it again. So we had the 6 electrons on each of these. And when we started pairing them up, we quickly saw that the only way to satisfy the octet of the outer 2 oxygens without breaking the octet of this oxygen was to move this electron over. So when I say I'm moving an electron, that means that the thing I moved it from is going to have a positive charge because I've removed an electron, and the thing I'm adding it to has a negative charge because I've gained an electron on that oxygen, okay? And nothing happened to this oxygen, so that one is 0, okay? And then once we've done that, so let me show the movement of that electron. Now we're going to pair up these guys. Let me do it in yellow again. Those are the bonds. We're going to pair up those guys to make that double bond. Okay, so I guess you could look at the formal charge simply by going through the process of drawing out the Lewis structure, and then you'd be able to see if you moved an electron anywhere. But let's pretend that instead of drawing the Lewis structure, I had just given you this Lewis structure and said, what is the formal charge on each of these atoms? Okay, so formal charge, you're going to take the valence electrons in what we call the free atom. So like not bonded to anything. In this case, it's 6 for the oxygens, right? And then you're going to subtract the valence electrons in the bonded atom, like within this molecule. So how do we count valence electrons within the molecule? This is where we split those bonds and assign one of the electrons in the bond to this oxygen and one of the electrons in that bond to that oxygen. Okay, we're going to do the same thing, kind of draw these same circles on the other 2 oxygens. Okay, now we've divvied out the oxygens and we can count up what the valence electrons are in the each bonded atom based on how we've drawn the structure. So every single one of these is going to be 6, the formal charge is going to be 6 minus however many valence electrons it has now in this molecule. So I'm just going to write 6 minus, and we'll go through and look at them, okay? So this one here has 1, 2, 3, 4, 5, 6, okay? So the formal charge is 0. Same thing we set up there. When we drew the structure, we didn't move any of that atom's electrons. For the middle one, it only has 1, 2, 3, 4, 5. Okay, so 6 minus 5 is positive 1. Same thing we had up here. Why did that happen? Because we actually moved one of its electrons over to this atom. So it lost an electron, and the charge is going to be positive 1 if it lost an electron, because electrons are negatively charged. And then finally on this one over here, 1, 2, 3, 4, 5, 6, 7. So that formal charge is -1. Okay. Another way of doing it is if the bonds have what we call their traditional number of bonds. So like remember oxygen and everything in its column normally has 2 bonds. So if you have 2 bonds and 2 sets of lone pairs on oxygen or sulfur or let's see what else, selenium, okay, then that's going to have a formal charge of 0. If you had 3 bonds, like in this guy, then it's going to have a +1 charge. If you have 1 bond, it's going to have a -1. Another way to think of this is when things have their traditional number of bonds, so oxygen column having 2 bonds and 2 lone pairs, nitrogen column having 1 bond and 3 lone pairs, carbon having no lone pairs and 4 bonds, fluorine having 3 lone pairs and 1 bond. Those are the traditional number of bonds and lone pairs for those columns. If they match those, they're 0 formal charge. Okay? If they don't, you probably need to look at them and consider, like if they have less bonds than that, they're a negative charge. If they have more bonds than that, they're a positive charge. Okay? Hopefully that helps. Let me know if there are any additional questions.